morning, my dear students. I hope all of you are safe and getting ready for a big celebration the weekend. The festival of light is arriving this week, Deepavali. Be careful when you go for the crackers and the lighting, other things, right? Okay, so we are almost coming to the end of the lesson number 2, which is P block. So in the P block, we discussed about the characteristics of the different elements present in the P block, and after that we have taken only the 13th group. So in the 13th group we discussed some of the elements, some of the compounds of boron, then some of the compounds of aluminium. After that, in the 14th group we discussed about the compounds of carbon, particularly carbon monoxide and carbon dioxide. Then we moved on to silicon. So under the silicon we just discussed about two, that is silicate tetrachloride and silicones. And today we are going to start a very important topic called silicates, right? Silicates are almost the minerals which are found in earth as rock and sand, which is mainly containing two elements, that is silicon and oxygen. And this silicon and oxygen are present as the units of SiO4 4-. It's called silicate units, right? Containing silicon and oxygen. In this, every silicon is bonded with 4 oxygen atoms, and they are present tetrahedrally, right? And this is the simple topic of the silicates. And after that we move to the types of silicates. So under the types of silicates, the first type of silicates that we are taking up is orthosilicate. Orthosilicates are the silicates containing discrete units. Discrete means separate units of SiO4 4- units. So only SiO4 units are present with some metals. Those silicates are called as orthosilicates. So in these orthosilicates, every silicon atom will be bonded with 4 oxygen atoms. And it should be in the form of tetrahedron, right? So the tetrahedral form is mostly like this, right? Si, 1 oxygen here, 1 oxygen here, 1 oxygen here, 1 oxygen here. Actually this is behind the board, right? Each will have 1 negative charge because oxygen's 1 electron is bonded, other electron is left free. So this is the Si4 unit, which has got tetrahedral structure, and it has got, we have every silicon atom bonded with 4 oxygen atoms. So it is in short represented like this also. So there are 4 oxygen atoms. These 4 oxygen atoms are represented like this, right? So we have 1 oxygen, this is the top oxygen, this is the oxygen at the left, this is the oxygen at the right, and this is the oxygen which is behind, right? Now where to put the silicon atom? Silicon atom we will put in the center as a dot. So this is representing silicon, right? You got to note it very carefully. In all the diagrams we are going to put like that only. This is the center position of this tetrahedron, and this oxygen on top, this oxygen at the left, this oxygen at the right, this oxygen behind the board. And these silicon atoms are bonded with all the 4 oxygen atoms. So this is bonded with this is bonded with this is bonded with this is also bonded with this, right? So this is the silicate units. Now how to put the charge? This oxygen has got negative charge, This oxygen has got negative charge. This oxygen has got negative charge. Right? This is how we put the negative charge. Right? So we have only, the bonds are only this. This is only to indicate the shapes of the orthosilicates. For the orthosilicates, the example that is given here is phenacite. Phenacite is an orthosilicate which is the silicate of beryllium. It is beryllium silicate, right? And there is one more silicate that is also given as the example, that is the olivine, which is the magnesium silicate. These are the examples of orthosilicate. So orthosilicates are the silicates which are containing the discrete units of SiO4, right? And in that, every silicon is bonded with 4 oxygen atoms tetrahedrally, and the structure is represented either like this or like this. So this is how it has to be presented, right? This is the first type of silicates. And the second type of silicate is pyrosilicates. So pyrosilicates have the general molecular formula of Si2O7 6 minus. This is the formula for pyrosilicate, Si2O7 6 minus. In this, what is happening is two SiO4 units are linked. Using oxygen atom, right? So it is represented like this. So right, so this is one silicate, SiO4, and silicon is at the center, right? So we connect this like this, and the bonds are formed like this, right? Now this oxygen becomes common for the next one also, right? And we have one silicon, one oxygen in the middle, one silicon, and the bonds, right? So we got how many silicon atoms? 2 silicon atoms. One silicon here, another silicon here, and we have got 1, 2, 3, 4, 5, 6, 7 oxygen atoms. And how to put the charge? We can put the charge for this, minus 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 charge for this, right? So we get how many minus? 1, 2, 3, 4, 5, 6. That's why 6 minus. There is no minus charge for this oxygen because it is bonded with 2 silicon atoms. So this silicon is also bonded with this silicon is also bonded with this. Therefore, it does not get a charge. And the example for this is given as tartrite, right? And this is scandium pyrosilicate, right? But this can continue as a giant molecule also. A number of Si2O7 units can be connected also. So this is the second type of silicate. And the third type of silicate is cyclic silicates. So these are the silicates atoms which are containing the units of SiO3 n times 2n minus. It's a formula for this also. So cyclic silicates are the one in which every silicon will have 3 oxygen around it, right? And there will be n units which will be connecting with each other, right? Now, how to draw the structure for this cyclic units, okay? And it goes like this. We have one SiO3 unit like this. So this is Si, right? And the second one goes like this. The third one is like this. Right? So we have 3 silicon atoms. This is also silicon and this is also silicon. And we got how many oxygen atoms? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's why it comes to every silicon and the oxygen are in the ratio of 3:9. That means it comes to 1:3. Therefore, the molecular formula comes to SiO3, right? So this is one of the cyclic structure that can be indicated, right? How to put the charge? Minus charge here, 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 and minus charge here, right? But not for these 3 oxygen atoms, right? So here, every 2 oxygen atom is being shared by 2 different SiO4 units. So there are 3 units. So 2 into 3, how many minus charge? 6 minus charge, right? And for this, we take the example of beryl. Beryl cyclosilicate, which is called the molecular formula Be2 Al2 SiO3, 6 times, right? So instead of 3, you can even have 6. So how to have 6 SiO3 in the, for this, to draw this, put like this first. One hexagonal structure to bring 6, right? And after that, put oxygens. Right? Now, one oxygen here with silicon here, and similarly one oxygen here with silicon in the middle. One oxygen here with silicon in the middle. One oxygen with silicon and one oxygen here. One oxygen here, one oxygen in the middle. One oxygen here, silicon in the middle. Right? Now we have 6. This also is a type of cyclic silicates. Right? So we'll have 1, 2, 3, 4, 5, 6 minus plus 7, 8, 9, 10, 11, 12 minus charge. This is also a type of cyclic silicates, right? So these are the three types of silicates that we have learned today: orthosilicate, pyrosilicate, and cyclic silicate. Cyclic silicate will always go in numbers of 3, 3, 6, 9, like that. You can keep on extending the number of silicates, right? The other silicates we'll see tomorrow. Okay? Take care.